Welcome to the 8th video lecture of my lecture series on fundamental physics. In this video, we will talk about law of conservation of angular momentum. So what is law of conservation of angular momentum? If the total external torque acting on the system is zero, then the angular momentum of the system remains constant. In law of conservation of linear momentum, we talk that if the total external force acting on the system is zero, then the linear momentum of the system remains conserved. Since we are talking about rotational motion, here the force is replaced with the word torque and linear momentum is replaced with angular momentum. What is angular momentum? Angular momentum is product of moment of inertia and angular speed. So what is inertia? Inertia is inability of any body to change the state of its motion. If it is at rest, it would remain at rest if there is no external torque acting on the system. And if it is in uniform motion, uniform rotational motion, then it would remain in the state of uniform rotational motion until an external torque is acting on the system. Now, we know that angular momentum is a vector quantity. If I'm saying angular momentum of the system remain constant, this comprises of two things. One is magnitude, another one is direction. So for angular momentum to be conserved, its magnitude and direction, both things need to be same. There are many applications of law of conservation of angular momentum. Look at this one. Here is moon. We know that moon traces an elliptic orbit around the earth. Here, why does this happen? Why moon remain tracing an elliptic orbit around the earth, and it will keep doing again and again because there is no external torque acting on the system. It is zero here. So its direction as well as magnitude of angular momentum would be constant throughout the motion. That's why by using the definition of law of conservation of angular momentum, we can say that moon would remain in the elliptic orbit around the earth as there is no external torque acting on the system. Now look at this example. Here this girl is spinning around. Here let's calculate inertia in both the cases. What is inertia? It is product of mass and square of distance. How to calculate this distance? This distance is between the point, any given point, and from the axis of rotation. This is axis of rotation, and here this would be the distance r. If I have to calculate r in this case, it would be large than this one. So inertia would be more in this case than this one. We have angular momentum as inertia into angular speed. This is angular speed. So if inertia is large for this system, angular speed would be lower, and if inertia is lesser in this case, here angular speed would be more. So that's why on bringing the arms and legs together or closer to the body, the moment of inertia decreases and angular momentum would increase in this case. So these were two examples from law of conservation of angular momentum. If you have any doubt, you can post it in the comment section. Thank you for watching.